Tyndall effect. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air. When a beam of light strikes such fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusively by these particles. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. It is named after the 19th century physicist John Tyndall. Tyndall discovered that when a strong beam of white light is passed through a colloidal solution, light is scattered by the colloidal particles. This scattering of light is called the Tyndall effect. The illuminated beam or cone formed by the scattering of light is called Tyndall beam or Tyndall cone. The path of the light becomes visible when viewed from a direction at right angle to that of the incident light. This phenomenon is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. Thus, scattering of light makes the particles visible. Tyndall effect can also be observed when sunlight passes through a canopy of a dense forest. Here, tiny water droplets in the mist scatter light. The color of the scattered light depends on the size of the scattering particles. Very fine particles scatter mainly blue light, while particles of larger size scatter light of longer wavelengths. If the size of the scattering particles is large enough, then the scattered light may even appear white.